section before spring break on distance and using coordinate geometry. So to start off our warm-up, they have us intro into what we're going to be talking about. It says Vicky is standing on the corner of 7th Street and 8th Avenue. Her brother Scott is at 2nd Street and 3rd Avenue. So if we look, they have them labeled 7th Street and 8th Avenue. Here is Vicky, and 2nd Street and 3rd Avenue, here is Steve. They want to know what is that distance that Vicky and Steve have to walk to get to the other person's house. It says, so how many blocks would Vicky have to walk on the sidewalk to get to Scott? So Vicky would have to walk over all the way along here, walk 1, 2, 3, 4, 5 blocks, and then down 1, 2, 3, 4, 5, another 5 blocks. So she would have to walk a total of 10 blocks. Number 2 asks, what is the diagonal distance in terms of number of blocks that they are apart? So they're asking, what is the distance from Vicky to Steve? So if they got to walk the shortest distance. And I know it's a surprise, but we're going to use Pythagorean theorem. So 5 squared, because we have a right triangle, plus 5 squared is going to be is 50 squared. So we'll write that 5 squared plus 5 squared is going to equal that c squared. This is equal to 50 equals c squared. Take the square root. Take the square root. If we simplify it, it'll be 25 and 2. And that'll have a perfect square of 5 and 5. So it'll be 5 times the square root of 2. Or if we wanted to find that decimal, it would be approximately 7.07 if we round to the nearest hundredth. So 5 times the square root of 2, which is approximately 7.07 blocks. So as you can see, when we're talking about trying to find distance between 2 points, we always want to find that shortest distance, a single line connecting the 2 points, and to do that, we can always create a right triangle. So we're going to continue on with the lesson. It says investigate. It says for graphs A through D, use each segment as the hypotenuse of a right triangle. Draw the legs along the grid line and find the length of each segment. So we are finding the distance between these 2 points. So we're going to draw the legs of a right triangle and then use the Pythagorean theorem. So we have 1, 2, 3, 4, and 2. So we're going to say 4 squared plus 2 squared is going to equal my hypotenuse. So this is going to end up being 20 equals c squared. Take the square root. That's going to simplify to be, let's see, 4 and 5, and then that's going to be 2 and 2. So those 2's are going to come out. So it'll be 2 times the square root of 5. Then, this guy, we can put our legs on either side. I'm going to go below so the hypotenuse is above the 2 legs. And we're going to have our legs be a length of 2 and 1, 2, 3, 4, 5, 6, and 6. So 2 and 6. So again, using Pythagorean theorem, we'd say 2 squared plus 6 squared equals c squared. Simplify that and you'll end up getting square root of 40 equals c squared, or c, sorry. And then we can simplify our radical. We'll end up getting 4 and 10. This is 2 and 2, so we're going to say 2 times the square root of 10. So moving on, this time it says graph each pair of points, then find the distance between them. So we're going to plot -1, -2, and 11, -7. 1, 2, 3, 6, 7, 8, 9, 10, 11, down 7. 1, 2, 3, 4, 5, 6, 7. 11, -7. There we go. So we want to find that distance between the 2. So I'm going to make a right triangle. Alright. Now I could count all these, just like I did in the previous example. 1, 2, 3, 4, 5. Or this is a lot of counting squares, so I can say, well, I know my horizontal is my x value, so the difference between from 11 to -1, I could say 11 minus -1, that would be a total of 12. And so now if I use my Pythagorean theorem, I'm just going to say, all right, 5 squared plus 12 squared equals c squared. I end up getting 169 equals c squared. Take the square root, so my hypotenuse is going to be 13. Next one, plot -9, -6, 1, 2, 3, 5, 6, 7, 8, 9, down 6, 1, 2, 3, 4, 5, 6. There's 1 point, and then 3, 10, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I want to find the distance between those 2 points. So I'm going to connect them, draw in my legs, and then I can do, again, Pythagorean theorem. I'm going to say, okay, that the legs here, that's my difference in x. So I could say -9 minus 3, that'll be -12. I can't have negative distance, so it's going to be 12. And then my y values are up and down. So 10 minus a -6, that's going to be 16. So now my hypotenuse, Pythagorean theorem, 12 squared plus 16 squared equals my c squared. That'll end up giving me 400 equals c squared. So my c is going to be 20. Now what happens, it says if your points are so far apart that it's not practical to plot them. For example, what if the distance between a point A is 1534 and B is 4270? That's going to be pretty annoying to have to plot those. So we could use a formula that uses the coordinates of the given points. That would be very helpful. So to find this formula, they say, you first need to find the lengths of the legs in terms of x and y coordinates, just like we were doing in that previous example. So from your work with slope triangles, you know how to calculate horizontal and vertical distances. So we see, just like we did with our previous example, to find that distance between the x, the horizontal, we look at the difference in the x. So if we call this point x1 and this y1, and this is our point 2, we could call this x2 and y2. We're going to say, okay, well then to find that horizontal distance, we look at the x values. So we'd say 42 minus 15. So we'd say x2 minus x1. Or in our example, it'd be 42 minus 15. Now it says write a similar expression for the length of the vertical leg using the y coordinates. So again, vertical is the y, so we'd say y2 minus y1. Or in this example, it'd be 70 minus 34. So now it says use your expression from steps 3 and 4 and the Pythagorean theorem to find the distance between points A and B. So we would say, okay, well then it's 42 minus 15 squared, because that's my horizontal, that's this leg, plus, let's do this in a different color. Here I'll line, so this is green. The other leg we'll do in pink, plus 70 minus 34 squared equals my hypotenuse squared. So we'll do that one in orange, equals c squared. So that's this one. So now let's go ahead and generalize. We said, well, this was my horizontal leg, so this is x, oops, I want to do that in green. This was x2 minus the first x point, x1, squared, plus my y points, that was y2 minus my first y point squared equals my hypotenuse squared. So it says let's generalize what we've learned. That's what we did in this row. So let's write this in. AB squared, or in other words our c squared, equals x2 minus x1. So just the difference in the 2 points squared, plus y2 minus y1, our second y point minus our first y point, squared, is equal to our hypotenuse squared, or c squared. Now notice I have the x2 point first and my y2 point first. You could also flip-flop that and say x1 minus x2, as long as this was consistent and said y1 minus y2. Or let's say we don't want AB squared, we want AB, just like we want C, not C squared. We would then take the square root of it all. So this is just going to be, the distance formula is the square root of everything that's in this above line. So we're going to rewrite this as square root of x sub 2 minus x1 squared plus y2 minus y1 quantity squared. So let's try an example with that. I'm going to rewrite this. We know our distance formula is now the difference, so x2 minus x1 quantity squared plus y2 minus y1 quantity squared equals our hypotenuse, C. So, I meant to have an example right here. I'm just going to write it right above. So we said our example on your note sheet says example 1, and it says use the distance formula to find the distance between 8, 15, so A, we're going to do a new sheet. A is 8, 15, and B is negative 7, 23. So again, these are pretty far spread apart points, so we're just going to use our distance formula. So we're going to remind ourselves this is the x, and this is going to be the y coordinates. So we're going to rewrite that formula. Square root of x2 minus x1 squared plus y2 minus y1 quantity squared. That is our distance, equals distance. So let's just find those differences. So let's call this x1, this one x2, this y1, and y2. So we're going to say x2 is negative 7 minus 8 quantity squared. That says a negative 7 minus 8 quantity squared plus my y coordinates. That's going to be 15 minus my, I'm just messing this all up. We want y2 first, so 23 minus 15 quantity squared, and we're going to take the square root of that all. And this is a 7. So we're going to, let's simplify what's inside that radical. Negative 7 minus 8 is negative 15. And we're going to square that whole thing. So that means negative 15 times negative 15. And then plus 23 minus 15 is 8, so 8 squared. So if we simplify that, this is 225 plus 64, so that ends up being the square root of 289, which equals 17. So the distance between those 2 points is 17. So now finally, we can actually use the distance formula to write an equation for a circle. So if we look at this circle, it says write an equation of the circle with a center at 5, 4, and a radius of 7. And it says let x, y represent any point on the circle. The distance from x, y to the center, circle center, 5, 4 is 7. That means the radius is 7. Substitute this information into the distance formula. So if we think through, if we think through, if this being y, our x1 and x and y1, x1 and y1, and this being x2 and y2, let's write our formula where it would we would say, okay, well, we know that x2 minus my x point is 5, my x1 quantity squared, plus my y points would be y2, we don't know what y2 is, minus 4 quantity squared. And we're saying that equals, if I draw in my right triangle, so here's my differences in x, here's my differences in y, this part is my hypotenuse squared, equals 7 squared. So actually in general, the way that we define a circle is by writing an equation saying, if given the center of our circle, in this case it was 5, 4, it's always just x minus our x coordinate of the center plus y minus our y coordinate of the center equals the radius squared. So in an equation of a circle with a radius, we're going to call it r, and the center, where this center was 5, 4, we're going to call it hk. Then our formula is going to be x minus h squared, that's the y coordinate of the center, plus y minus k quantity squared equals the radius squared. That is the equation of a circle. So if they ask us to write the equation of a circle with a radius of 4 and a center of negative 5, 7, then we would write, alright, well, let's label these. This is h, this is k, and this is my radius. So we're going to use this formula. So we're just going to say x minus h is a negative 5, so minus negative 5 quantity squared plus y minus k is 7 quantity squared equals my radius squared equals 4 squared. So if we simplify this, this would be x minus a negative is of x plus 5 quantity squared plus y minus 7 quantity squared equals 16. And then finally, so that is our equation of our circle. Then finally, example 4, what's the center and radius of a circle that has this equation? So keep in mind our formula is x minus h squared plus y minus k squared equals the radius squared. So this is my radius squared. If this is radius squared, then my radius must equal square root of 36 is 6. Because I don't want to take the square root of that. Then this is x minus h. So h is negative 5. So my center, remember, is hk. So h is 5. And k, this says y minus k. So since this is positive, I know that this is like saying minus a negative k. So k must be negative 3. If I need to, I could plug this in and say y plus 3 equals y minus k, and I could solve for k, and I could say, okay, subtract y, both y's cancel, and I'm left with 3 equals negative k, and then divide that by negative 1, divide by negative 1. I see negative 3 equals k. If that's an easier way for you to see that this is a negative 3. Otherwise, you can see that it's the opposite, so our k must be negative. So again, we can look at an equation and say, oh, the radius right away is 6, and the center is 5, negative 3. So you can take this time now to work on your homework and have a great spring break. Actually, get ready for your team quiz, which is on Thursday.